trigonometric ratios. Consider triangle PQR. Sin theta is PR over PQ. Cos theta is QR over PQ. And tan theta is PR over QR. We can show that tan theta is equal to sin theta over cos theta. From the above, sin theta over cos theta is equal to PR over PQ divided by QR over PQ. If we do cross multiplication, we'll end up with sin theta over cos theta is equal to PR over QR, which is tan theta. Derivation of sin squared x plus cos squared x is equal to 1. Consider the figure below. Using trigonometric ratios, sin x is equal to AC over R, and therefore AC is R sin x, equation 1. Cos x is equal to BC over R, and therefore BC is R cos x, equation 2. By Pythagoras' theorem, AB squared is equal to BC squared plus AC squared. Substituting equation 1 and 2 into the above, R squared is equal to R sin x squared plus R cos x squared. This is equal to R squared into sin x squared plus R squared into cos x squared, finally ending with R squared sin squared x plus R squared cos squared x. If we divide both sides by R squared, we'll end up with 1 is equal to sin squared x plus cos squared x, equation 3. Note that sin x squared is equal to sin squared x, and similarly cos x squared is the same as cos squared x. Using sin squared x plus cos squared x is equal to 1, we can have sin squared x is equal to 1 minus cos squared x, and also cos squared x is equal to 1 minus sin squared x. Given that tan squared x is equal to sin squared x over cos squared x, we can have tan squared x is equal to 1 minus cos squared x over cos squared x. Breaking this into separate fractions, we have tan squared x is equal to 1 over cos squared x minus cos squared x over cos squared x, which ultimately gives us 1 over cos squared x minus 1. Therefore, tan squared theta plus 1 is equal to 1 over cos squared theta. Now consider the equilateral triangle PQR. By Pythagoras theorem, QS plus PS is equal to 2. 1 plus PS squared is 4. Therefore, PS is equal to root 3. Sin 60 degrees is equal to PS over 2, which is root 3 over 2. Cos 60 degrees is equal to 1 over 2. Sin squared 60 degrees plus cos squared 60 degrees is equal to root 3 over 2 squared plus 1 over 2 squared. Which gives us 1. Therefore, it is true that sin squared theta plus cos squared theta is equal to 1. Let's take an example. Given that sin theta is equal to 1 over 5 and theta is an acute angle, find cos theta plus tan theta, leaving your answer in third form. In our solutions, we know that cos squared theta is equal to 1 minus sin squared theta. Cos squared theta is therefore equal to 1 minus 1 over 5, which gives us 24 over 25. Taking square roots on both sides, we have cos theta is equal to root 24 over 5. Tan theta is equal to sin theta over cos theta, which is equal to 1 over 5 divided by root 24 over 5, which gives us 1 over root 24. And therefore, cos theta plus tan theta is equal to root 24 over 5 plus 1 over root 24, giving us 29 over 5 root 24. Another example, show that cos squared theta over sin squared theta plus cos squared theta is equal to 1 over sin squared theta minus sin squared theta. In our solution, let's work with the left hand side only and ignore the right hand side for the meantime. Cos squared theta over sin squared theta plus cos squared theta over 1. The LCM of sin squared theta and 1 is sin squared theta. Sin squared theta divided by sin squared theta is 1. Multiplied by cos squared theta, we have cos squared theta. Plus sin squared theta divided by 1 is equal to sin squared theta. Multiplied by cos squared theta, and we have cos squared theta sin squared theta. But we know that cos squared theta is equal to 1 minus sin squared theta. Substituting all cos squared theta, we end up with 1 minus sine squared theta plus 1 minus sine squared theta times sine squared theta over sine squared theta. If we open the brackets and multiply, we end up with 1 minus sine squared theta plus sine squared theta minus sine to power 4 theta over sine squared theta, which is equal to 1 minus sine to power 4 theta over sine squared theta. If we break into separate fractions, we end up with 1 over sine squared theta minus sine to power 4 theta over sine squared theta. And if we cancel the right hand side, we end up with 1 over sine squared theta minus sine squared theta, which is the same as the right hand side of our original equation. Attempt the quiz below. Trigonometric graphs. We saw in Form 3 the graphs of y is equal to sine x, y is equal to cos x, and y is equal to tan x. We now look at other types of trigonometric graphs. Properties of graphs. Amplitude is the magnitude of the minimum or minimum value of the graph. Period is the time or length along the x-axis it takes for the graph to repeat itself. A crest is the highest point, a trough the lowest point, and wavelength is the distance between two successive crests or troughs. Graphs of y is equal to a sine theta and y is a cos theta. Let us compare the graph of y is equal to cos theta and y is equal to 2 cos theta. From the table of values, we shall have the following. If we plot these values, we shall end up with the following graph. Next are graphs of y is equal to a sine b theta and y is equal to a cos b theta. Let us compare the graph of y is equal to a half sine 2 theta and y is equal to sine theta. For the range of 0 to 360 degrees, we can have the table of values as shown below. Plotting these values, we get the following graph. Solving trigonometric equations. The trigonometric equations have infinite solutions. For example, cos x is equal to 0. Even 630 degrees has cosine of 0. It is therefore specified the range of solution required. For example, find cos x is equal to 0 for the range of x from 0 to 360 degrees. Let's take an example. 2 sine into x plus 30 is equal to 1 for the range of x from 0 to 360 degrees. In our solution, sine into x plus 30 degrees is equal to 0.5. We find the angle represented by 0.5 and we find that x plus 30 is equal to 30 degrees. We know that signs are positive in the first and second quadrants. In the first quadrant, the angle is 30 degrees. In the second quadrant, the angle is 150 degrees. Hence, we shall have x plus 30 is equal to 30 and 150, and x is 0 and 120 degrees.
The importance and role of communications through broadcasting. I learned that.
Understanding the balance between vision and expression. I learned that.
Exploring the issues of our time. I learned that.
How to think like a great designer. I learned that.
Integrating creativity with professionalism. I learned that.
That's where I learned.